So now we're on to graphs of secant and cosecant. Now secant and cosecant have distinct looking graphs, and they do have the asymptotic behavior similar to tangent and cotangent, but they're very much related to a single, in the case of secant, cosine, in the case of cosecant, sine, regular trigonometric function, right? So it turns out when we're constructing the graphs, as well as whenever we're asked to do something with them, we're going to use this relationship pretty much exclusively. So similar to what's happening when we do 1 over cosine, this is a graph of cosine, right? We are going to see that secant is going to have an asymptote whenever cosine is equal to 0. So here, right? Now something else interesting happens too. And maybe I shouldn't use red because I already have red. We'll use blue. If you look at this point right here, 1, 1, 1, right? That'd be 1 divided by, well, if cosine is 1, 1 divided by 1 is 1. So that means that each of these points are equal to 1. That is the same as the maximum. And it turns out if you take 1 divided by -1, you get this -1, which means that at the max and mins, right, the maxima and minima, that's fun to say, right, maxima and minima, are going to end up indicating a portion of the secant graph. Now, same sort of idea. We're taking 1 and we're dividing it by a number that's close to 1, right? But it's a little bit less, so it's going to go up, and it's going to be positive, yes? As we get closer and closer here, just before the asymptote, we're taking 1 and dividing by a really small number, which means that this is going to get very large. So it turns out what we have, and if we go the other direction, the same things happen. It's nice and symmetric, right? It turns out that these end up being what looks like, but is not, or not, right, a series of almost parabola-like things. So there's minima and maxima, and it's just related to the graph of its parent function, in this case, cosine for secant. So whenever you're graphing secant, usually what you end up doing is graphing cosine and then doing this off of the maxima and minima, right? Knowing that the asymptotes are going to be at these inflection points, right? That's usually how that goes. Or if we're asked to write an equation for secant, what we do is we figure out what the cosine graph would be and we just do the same modifications. We'll talk about that here in a sec. Now, cosecant works in a very similar fashion, except it's based on sine. So now we're looking at asymptotes when sine is equal to 0. So once again, these graphs are going to be out of phase in a similar fashion to tangent and cotangent because of where the zeros are relative to each other in sine and cosine, right? Now, let's get that fixed a little bit. You're also going to see exactly the same behavior when it comes to the maxima and minima, and you're just going to get this series of parabola-like things, though they're not, because it's being an asymptote to this, right? It's asymptotic to this because we have a series of vertical asymptotes repeating over and over again, right? So these are very similar graphs, but they're out of sync slightly, okay? Now, because they're based on just one graph, however, if you look, we have this positive portion, we have this negative portion, and this covers the whole of this secant, and then we can see this positive, negative, and this is going to repeat ad infinitum, which means that the period is equal to 2 pi radians. So the only one that has a special period, only two that have a special period, are the tangent and cotangent graphs, because the same is true for cosecant, being related to sine. Okay, so a quick rundown. So the upshot is really that if you can graph sine for cosecant or cosine for secant, you're good to go. Basically, if you're asked to graph something that's cosecant, graph the sine model. In other words, replace the cosecant CSC with an SIN, graph that, and then do the little u's off of it, right? Same thing for secant. Whatever modifications, amplitude, period, phase shift, and midline, that are being made to the secant or cosecant are the same as the corresponding sine or cosine graph, okay? And so what this means is, if you were asked to graph this, or from a graph write this, what you'd want to do is you'd want to write the sine model for this, or the cosine model for this, right? So if you gave you the equation, you'd graph it as if it were sine or cosine as appropriate, and then do the little u's off the maxima and minima like we saw, right? In fact, a lot of the time people will graph the actual sine or cosine graph and then add the secant or the cosecant as a little guide. It just makes it easier, right? Okay. So these are very much closely related, as you might expect, to sine and cosine, because they're based on sine and cosine. Okay? So that is secant and cosecant in a nutshell.